Alright, in this video we are going to look at solving quadratic inequalities. So a quadratic equation that has an inequality, a greater than sign or a less than sign with the equal stuff in there too. Okay, just a quick thing about inequalities. Typically if you're going to solve an inequality, this isn't one, but this one down here is. If I were to solve this equation, I'd subtract 3 from both sides, I'd get 2x is equal to 4. Divide both sides by 2, I get x is equal to 2. And that's the number that I could plug in there that would make this statement true. If you have an inequality, you get more than one answer. Like you could have a lot of answers that could solve that. So for example here, if I wanted to solve this, I could again subtract the 3. Notice how I treat it just like an equal sign. So it'll be 2x is less than or equal to 4. And then I'll divide both sides by 2. And so I'll get x is less than or equal to a positive 2. So in this case here, to make this statement true, I could use any number for x as long as x is less than or equal to a 2. So I could put a 2 in, that would work. And I can put any number that's less than 2, like 1 or negative 0.5 or anything as long as it's less than 2. All of these numbers are solutions to that equation. Now when we talk about quadratic inequalities, it's a similar kind of thing. So what I'm looking for in this question here is I'm looking to find all the values of x that make this statement true. So what are the x's I can put in there that will make this thing greater than 0? There's probably going to be quite a number of them. Now to solve this graphically, you just take a quick look at this graph here. This is the graph of x squared minus 2x minus 3. And as I take a look at it, what I'm looking for are all these values that are greater than 0. And really what I'm looking for are y values. So I'm asking, when is the y value greater than 0? So I take a look here and it looks like here's the y equals 0 line. So anything above that counts. So it looks like from here going this way, that counts. And here going this way, that's good too. But this stuff down here, all of this stuff, isn't any good because that's where y is less than 0. So I can't include any of that stuff in my solution. So what I can include is this part here up there. I can include this part of the parabola and that part of the parabola. And so a way I could say that, I know this goes on forever, and this one would go on forever as well. So I would say something like, well, x, in order to make this statement true, has to be less than, that looks to be negative 3. So x has to be less than negative 3. And it also looks like x can be greater than a positive 1. So those would be my two answers to this question to say what values of x would make this statement true. These are them. So if your x is less than negative 3, it works. If your x is greater than 1, it works. Let's just try one for example. Let's try, say, minus 4. So if I plug a minus 4 in here, let's just see if the statement's true. So minus 4 squared plus 2 times minus 4 minus 3, is that greater than 0? Okay, let's see. Minus 4 squared is 16. 2 times minus 4 is a minus 8. Minus 3, is that greater than 0? 16 take away 8 is 8. 8 take away 3 is 5. Is 5 greater than 0? Yes, it is. Therefore, negative 4 is a number that works. And actually, any number, as long as that it's less than negative 3, is going to work. In addition, you can say any x that is greater than 1 will work. So this is one way you can express that answer. Another way of expressing the answer could be using that interval notation. So since this goes on forever this way and on forever this way, you could say something like this. So your answers for x are all the numbers starting at negative infinity and going all the way up until negative 3. And since it's not including a negative 3, I just put a curly bracket. And then I can say everything from 1 up to a positive infinity, that works too. Again, I use a curly bracket to indicate that it does not include 1, It's just everything above 1. And then you put a union sign in the middle saying it's both, your answer is both of those things together. Let's try another one. Here they say solve this. It's an inequality. I've already put the graph there, see, and we've already seen this graph. But another way you could solve this is simply finding points on the graph that are, I guess, points of interest or points of importance. And to find those, you'd find the x-intercept. So if I treat this just like an equals 0, I could factor this. And if I were to factor that, it comes out to, looks like this is x plus 3 and an x minus 1. So a value of x plus 3 is greater than 0. I could put that in. Really what I want to just say right here is that -3 is an important point. Okay, so I could say x plus 3 equals 0, and then solve for x, it's -3. For this side here, it's x minus 1 equals 0, so x is equal to 1. So something special happens at -3 and positive 1. I can already see that right here on this graph, but let's pretend as though we can't see the graph. So if I have, say, a number line that's like this, I guess I can use a quadrant. At an x value of -3, something special happens. And the next value of positive 1, something special happens. I know it's a quadratic, so it has to look like this or like this. It's positive, therefore it looks like this one. So I could really, just based on what I know about quadratics, I could say the graph is going to look something like that. But if I didn't know, what I could do is get some numbers. So like I could try maybe a -1. And I know this interval in here is all going to be the same. Okay, so this interval in between the -3 and positive 1, it's all going to be the same. So let's try a -1 and just see whether it becomes positive or negative. So into this equation, I'm putting in a -1 squared plus 2 times -1 minus 3. Is that greater than or 0? Okay, -1 squared is 1. 2 times -1 is -2, minus 3. And I'm wanting to see whether that works. 1 take away 2 is -1, so it's -4. Notice that -4 isn't greater than 0, so it doesn't belong to the answers for x there. But one thing I get from this is that my answer to this is a negative number. So at -1, my graph will be -4. Since it's negative, it doesn't fall into that category where things have to be bigger than 0. Therefore, this piece in between here, between -3 and positive 1, does not count for an answer to make things bigger than 0. Okay? So again, from this one, you'd say everything above this, is it a greater than or less than? Oh, it's greater than. So anything from here this way and from here this way would be solutions to that question. Here's another example of that. This one, it's got 3 factors. If there's 3 factors, then there'd be 3 important points on my graph. Let me put my graph over here. So for this one, it would be x equals 0. That's that point right there. For this one, be x equals -2. So that's that point right there. And this one, positive 3. That's that point right there. So something funky is happening in between these two. Something's happening in between these guys. Something is happening above that, and something happening below that. Now we could maybe call each of those ranges a letter. Like we'll call this one A, this one B, this one C, this one D. And then what you do is you plug in a number that's sort of in the A category. Like this is -1, -2, like -3. I could plug in a -3 and see what happens. If my answer to this is positive, then that line would be above this somewhere. If the answer to this comes out to be negative, it would be below this line. Let's try. So put a minus 3 in there. So 5 times minus 3, and then minus 3 plus 2 is a negative 1. Minus 3 minus 3 is a negative 6. And so if I times all that together, a negative negatives cancel, times a negative is a negative. So the answer to this is a negative number. Therefore, everything in range A is below the axis. So the graph's got to be doing something like coming up like this, something like that, but it's got to be below the axis. Let's see what happens in this B interval. So why don't we try a negative 1? So let's plug in a negative 1 everywhere I see an x. Negative 1 plus 2 would be a 1. Negative 1 minus 3 is a negative 4. Okay, if I multiply all this stuff together, that's a negative 1. Negative times negative is positive. It's going to be a positive 20. Therefore, everything in this B range is going to be positive. So the graph might come up like this and come down at that point there. And you can continue on. Pick a number for the C interval. Maybe pick a 1 and see what you come up with. And then do the same thing for the D interval. Also use your calculators to help you. You could plug this whole thing in, have it y equals 5x times, etc. And that'll show you what the graph looks like for that interval or inequality. Here's what the graph looks like, and we're sort of on the right path there. It came up through that point, back down, and went up again. And I can get a shape that's similar to that just looking at those intervals. All right, take note of it in your book. They have a little table or cheat sheet to help you figure out how to solve a rational inequality. Not a bad idea to do these. Let me do one more question, and then you can try some. So I'm going to try and use these steps. Change the inequality equals. Find the numbers for which the denominator in the equality is not defined. Okay. Use the numbers found in steps 1 and 2 to divide the number line into intervals. Okay. Substitute a number into each interval to check it. Yeah. Select the intervals satisfied. And write set builder notation or interval. Yeah, we'll answer. Okay, so here's a question. So I've got x minus 1 over x minus 3 is greater than 2, and I want to solve that. So they say there to make it an equal sign. So x minus 1 over x minus 3 equals 2. Okay, oh, I've got the graph over there. We'll be able to see it later. Okay, now to solve this is in a fraction, so let's get rid of it. Let's multiply multiply each side by x minus 3 times this side by x minus 3. On this side they'll cancel, so I'll be left with x minus 1 is equal to 2x minus 6. Now let's bring the x over here and subtract it, so that would just be an x. And let's take the negative 6 over here and add it, so it'd be 6 take away 1, which would be a positive 5. So something happens at a positive 5. When I take a look at my graph here, I see, right there, something happens at a positive 5. Now, so that is solving, done that. So positive 5 is what we got. Find any number for which the denominator is not defined. In this question, what number can I not put in there? What number, if I put in there, makes it a 0? Be a positive 3. So something else funky happens at a positive 3. Then what I can do is plug in numbers to see what's happening in those particular intervals. So if I say plug in a positive 2, and I can see what this comes out to. It's going to be a negative. I can see in the graph that it's all negative there. And it looks actually like this one goes down and it'll approach 3 but never touch. And then it picks up here. It doesn't get to 3 or start at 3. It starts just past it, and then it comes down. It goes through 5. So that for this interval here, it looks like the graph is positive. From this graph down here, from this interval, the graph would be negative. Okay, I can look from the graph, but I could also plug in a 6 to see if what that comes out to. Okay, hopefully that helps you with 7.8, graphing quadratic inequalities.